Hey everyone, welcome back to Engineering Education. For this next problem, we are solving the following integral. We have the integral from negative infinity to plus infinity of sine omega t multiplied by the Dirac delta function of t minus pi divided by 3 dt. And here we're told that omega is equal to 2. And also we need to express this in radians. So as always, pause the video, give it a shot, and we'll go over the answer in a bit. So to go ahead and solve this, we turn to our FE handbook. And in the communication theory and concepts section here, we have a bunch of functions here. We have the unit step function here, the rectangular pulse. All the way at the bottom here, we have the unit impulse. So that's going to be your delta function. And here we have two properties that equal each other. We have the integral from negative infinity to plus infinity of this shifted x signal multiplied by the Dirac delta function. And then we also have its equivalent integral from negative infinity to plus infinity of some x of t with a shifted delta function. And so we're going to copy this property here. So that property of the delta function is called the sifting property. And so we're going to write that on the next page. So we have the sifting property. And that states that the integral from negative infinity to plus infinity of some x of t, delta function t minus t0 dt is equal to x of t0. And so that's similar to this equation here. So we're just going to replace x of t with our sine omega t. So we're saying that from negative infinity to plus infinity of sine omega t, delta function of our t0 is going to be pi over 3, is going to be equal to the sine, which is our original function, of t is equal to t0. So here we have omega, and then our t is going to be equal to t0, which is pi over 3. And so that becomes the sine of omega is equal to 2. So that's 2 pi over 3. And then that gives us the square root of 3 over 2. And that is our answer. And the important thing to remember here is just this sifting property and how we can use it to solve these integrals. So remember that the Dirac delta function is a function that's infinity at t is equal to 0, and it's 0 otherwise. So it's just a very, very long vertical line that goes to infinity. But one of the important properties of the Dirac delta function is that the area under the curve, or the integral, is equal to 1. And so this has an area of 1 whenever we take the integral from negative infinity to plus infinity. So that means that the integral from negative infinity to plus infinity of the Dirac delta function dt, by definition, is equal to 1. So, did you guys get that? Let me know in the comments below. If you haven't already, please subscribe to the channel, and I'll see you guys in the next video. Until then, enjoy engineering.